so we're talking about more about domain and range here. It's asking us to graph the function using a table of values and then use the graph to determine domain and range and give the y-intercept. I think that we should be able to determine all of this without having a graph also. So I want to make sure we can do that both ways. So my first question was it standard or vertex form? And it actually could be either. So remember, your standard form looks like this. The ax squared plus bx plus c. And so a is -1, b is 0, and c is 5. Now, I'm going to have to find the vertex, even though it doesn't ask for that. I'm going to have to find the vertex in order to help me make a t-chart. And then my vertex will go in the middle. The other reason I want to find the vertex is that's going to help me find the max or min value in the range, because the vertex y value is the highest or lowest point on my graph. So if I do it in standard form, I'm going to have to find the vertex using my formula x equals -b over 2a. However, I could look at it in vertex form. A is -1, h is 0, and k is 5. K is very different than c, but this case k is 5. So here I can look at it and tell you my vertex is 0, 5. And how do I get my axis symmetry? Well, it always cuts through the vertex, so it's that x value. So in vertex form, the vertex is just the hk, and the axis of symmetry is x equals h. So you could do it either way. I'm going to go with vertex form, knowing that my vertex is 0 for h and k is 5. Now, it doesn't ask me for that, but I'm going to use it. Without even graphing it, does this graph open upward or downward? The a is -1, isn't it? So my graph is going to open downward. Now, before I do anything else, my graph's opening downward, no matter whether it opens up, down, it's a very narrow graph and stretched vertically or horizontally stretched wide. My domain always is infinity, negative to positive infinity. You can square and multiply, add, subtract any real numbers, and you will get out a real number. Now, the range, can you, without graphing it, picture this being my vertex of 0, 5? That y value, y equals 5. That's the highest point. So I have a max at y equals 5. Without even graphing it, I know that from the vertex. And this is my little visual to help me. So let's think about the range. If my highest point is 5, my lowest point is -infinity. So low to high. And you probably should make that look a little bit more like an infinity symbol rather than an 8. Okay, so I got all of that information just by knowing the vertex and understanding that. Now, one more issue here. What's the y-intercept? Well, we put the 0 in, don't we? So it'd be -0 squared plus 5. So when I go to graph it, guys, my y-intercept is my vertex. My axis of symmetry is x equals 0. So I'm going to sketch that in. That means my y-intercept is not an extra point, so I'm going to have to do some work. So let's put in some extra numbers like -1, -2, +1, and 2. So take a minute, find me these values. Now, I do want to remind you something. That negative sign is outside. So it is, put your x in parentheses. You have a negative, put in the -2, power on the outside, and then plus 5. Okay, so if you're one of those people who is looking at this going, oh, there's 2 negatives, I can cancel it, I won't even put it in the calculator, you will get it wrong, okay? If you put it like this in the calculator, you're going to be fine. But can we just talk about this algebraically? Can you pause for a minute, stop using your calculator and use your brain? Because this is a huge problem. Why can't I cancel these negative signs? Okay, this one's inside the parentheses with the power. Order of operations, don't exponents come first? This is really like -1 times it. I have to do exponents before I multiply. It's just basic order of operations. So this is like the opposite of -2 squared. And so I really want to stress that. So I get a +1. So you can't lose a negative side, and you can't just cancel them because you see 2 of them because of the power. All right, so with that in mind, go ahead. I know you're starting to do some algebra here. So this would be a -1 plus 5, and I should get 4 there. All right, so go ahead, double check that you get the right numbers over here. All right, so we went ahead and finished the math. Let's go ahead and graph that vertex at 0, 5, and I'm going to graph my extra points here, negative 2, 1, and I have negative 1, 4. I have 1, 4, and 2, 1. There's my downward U-shaped curve. Make sure you fill that out. And then if you look at it, I do see that if I scan this, it always is running down, and then it stops here at that Y value of 5. Okay, with that in mind, what form is example 2 in? That is in vertex form, okay? That's vertex form. So go ahead. My first thought, I mean, we can fill in the domain, and we could definitely get the Y-intercept by plugging that in, but I really can't get the range or the max value until I get what? What do I need? Vertex. So you need to make sure you're comfortable and know your vertex form, the H and the K value. So I'll give you a minute, so go ahead and pause this video and try this problem before we go over it. All right, so with this being said, we need to make sure we look at this as x minus a negative 3 squared minus 2. So the H value is negative 3 and the K value is negative 2. So I can tell you that that is my vertex. My axis of symmetry would be helpful, and that's at x equals negative 3. So sketch in that x equals negative 3 here. I'm going to go ahead and plot that point at negative 3, negative 2. And without doing any other part of the graph, I know my graph's going to open upward because A is positive. If it opens upward, I have a minimum value. So having this little visual helps me. I know that the minimum value is at Y equals negative 2. So I'm going to be pretty picky. If you just say it has a minimum at negative 2, I'm being picky because I want you to know that it comes from the Y value of the vertex. So the max or min is not the vertex, but it comes from the Y value of the vertex, which also gives me my range, which the low is negative 2 and the high is infinity. Now, with that being said, we could do a quick sketch, but it told us to use a table of values. And so use your vertex to help you anchor the graph with your axis of symmetry. And then you pick some points below it. So I'm going to make that a 4 and pick some points above it. All right, so I have negative 5 as a positive 2. Does anybody agree with me? All right, negative 4 as negative 1, negative 2 as negative 1, and negative 1 would be also 2. And I'm just plugging those numbers in, doing the addition, squaring it, and then subtracting 2. So go ahead and graph that at negative 5, 2, negative 4, negative 1. I was doing this earlier and I thought, this does not work. I was graphing at negative 2, 1, and it was making this weird shape. So I knew something was wrong. You should get a nice fluent U-shaped curve. If you're not getting it, something's wrong in your algebra. Maybe your Y-intercept or your vertex was wrong. I didn't actually find the Y-intercept yet. When you put that in, you can't just say it's negative 2. That works in standard form. In standard form, when I put 0 in, it wipes everything out but C. In vertex form, when I put 0 in, I still have 8. So when I put 0 in, I get 3 squared minus 2. So that's 9 minus 2. I should have it at 0, 7. And so that would be another point. So you can see that my graph should actually come up a little wider, and I did not do a good job of extending that. And then if that's 3 points to the right, then it should be 3 points to the left. So hopefully your graph's a little neater than mine. I had to sort of push my edges there.